Here we have something special called Pascal's triangle, and it has a lot of applications in mathematics. However, we're only going to start with a few of those applications. Now let me show you how it's formed. First we start with a 1 in the top block, and then we move down to 1 and 1 here. Once we do that, then we start to have all 1s along the sides. Okay, and I'll finish that up. However, what we then want to do is we want to add these two 1s together to give us the answer to that block there. So 1 plus 1 gives us 2. All right, and we start building our blocks in much the same way. 1 plus 2 gives us 3. 2 plus 1 gives us 3. So now we have 1, 3, 3, 1. 1 plus 3 gives us 4. 3 plus 3 gives us 6. I meant to make that black. There we go. 6. And 3 plus 1 gives us 4 again. And so we're going to continue this process downward. 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 gives us 10. 4 plus 1 gives us 5. We can see the pattern starting to be built here. Remember, 1s are all along the sides. We keep moving down with those 1s along the sides, and everything else gets built by adding pieces of the blocks above together. So 1 plus 5 here gives us 6. 5 plus 10 gives us 15. 10 plus 10 gives us 20. 5 plus 10 gives us 15. And 5 plus 1 gives us 6. Moving down further, 1 plus 6 gives us 7. 6 plus 15 gives us 21. 15 plus 20 gives us 35. 20 plus 15 gives us 35. 15 plus 6 gives us 21. And 6 plus 1 gives us 7. And so what I would encourage you to do right now is to pause the video and complete Pascal's triangle. And when you unpause, you will finally see the answers all the way down. Double check yours with those on the video. Okay, double check all your numbers here. So these are the row sums for Pascal's triangle. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. And so here I've replicated those numbers so that we can answer our next question, which is, with each row doubling the previous row, can we predict the row sum for row 20? So what we can do, I've already started making a table and you've already started doing that with me, is to continue our table until we get to row 20. And so we have 14, 15, 16, 17, 18, 19, 20. Okay, so let's double each of these. You can pause the video now and complete this, and when you turn the video back on, you'll see my answers as well. All right, so it worked. So if we did want to figure out the 400th row and we didn't want to continue this table, the 400th row would have an exponent of 399. Now, your calculator may or may not be able to handle this. And when I used my calculator, it listed it as a scientific notation number, so it looks something like this: 1.29 11 24939, and then times 10 to the 120th power. And that's because this is a really, really big number. So my calculator can handle it. It didn't say that it couldn't. It just rewrites it so that it is in scientific notation form rather than the number fully and completely out. So that's just an idea about how to complete this. Pascal's triangle has really cool applications to not only arithmetic and algebra, but to courses that are further on up, including statistics and others.